Friends, let's discuss activating and deactivating groups. For discussing this topic, we consider the nitration reactions of some compounds. First, we have the benzene. It reacts with a mixture of concentrated HNO3 plus concentrated H2SO4 at 60 degrees Celsius, producing nitrobenzene. Okay, please. What happens? A mixture of these two acids, that is your HNO3 and H2SO4, first produce NO2. First produces mixture of these two produces NO2 positive, means this is your electrophile or a cation, right? And this NO2 positive attacks on benzene ring, which is a rich source of pi electrons. Benzene contains 3 pi bonds or 6 pi electrons, and those are attacked by, or benzene ring is attacked by the electrophiles. This is the first reaction which occurs at 60 degrees Celsius. Okay, please. Now we have the nitrobenzene. We carry out the nitration of nitrobenzene further. Reaction 1, reaction 2. Okay, please. Same reaction mixture, nitrating mixture, but the temperature here is 90 degrees Celsius. What do we get? We get this product, NO2 and NO2, 1,3-dinitrobenzene. Here the temperature is more by 30 degrees Celsius. Why? The question is why? Okay, please. Then third reaction. We have the toluene and nitrating mixture, which gives us NO2 positive electrophile, and here the temperature is 30 degrees Celsius. Okay, what do we get? We get two products, CS3, that is your NO2 plus CS3 and NO2. Here NO2. These are the two products. Okay, please. Simple. We get orthonitrotoluene, para-nitrotoluene, two products. Here the temperature is 5. So let's compare reaction 1 and 2. Okay, please. Benzene reacts with this nitrating mixture at this temperature, but nitrobenzene reacts at higher temperature. It means we have to supply more energy here. It means this compound is less reactive as compared to benzene. The more heating of reaction mixture here as compared to reaction 1 shows us that this compound is less reactive as compared to your benzene. And this is because of the deactivating effect of NO2 on benzene ring. And this is because of the NO2 group present on benzene ring, which decreases its reactivity. And we say it is a deactivating group. Here, in case of toluene, as compared to reaction 1, in reaction 3, less heat is required. that reaction occurs at lower temperature, means reaction conditions are milder. Means toluene is more reactive than benzene. That is why it reacts at low temperature with nitrating mixture, giving your this ortho para. Okay, please, nitrotoluene. So reaction, comparison of reaction 1 and 3 proves that CH3 group when present on benzene increases its reactivity towards the nitrating mixture. So it is a activity groups. So all the groups which are present on benzene ring, let's say X are of two types. Let's say X is equal to A, the groups which enhance the reactivity of benzene ring, and these groups are, let's say, NH2, OH, etc. OH, etc. Okay, please. OH, etc. These groups are हमारे पास. And some other groups, let's say X is equal to B. These groups decrease the reactivity of benzene ring, known as the deactivating groups. At B is equal to CHO, NO2, etc. So there are some groups which, when present on benzene ring, enhance the reactivity, increase the reactivity of benzene ring, and these groups are known as the activating groups. There are certain other groups like CHONO2 which, when present on ring, decrease its reactivity towards electrophilic substitutes. And these groups are known as the deactivating groups. Now why the groups, let's say A and B, increase and decrease the reactivity of benzene ring? So it is because of following reasons. The reasons are very much obvious. The reasons are very much obvious. Any group which increases the availability of pi electrons on benzene ring increases its reactivity. Any group, and the reactivity increases because of two phenomena. That is your plus I effect and plus M effect. For example, let's say nitrogen, when present on benzene ring, let's say this, removes sigma electrons from benzene ring. This is your minus I effect. Because of more electronegativity of nitrogen as compared to carbon. But it gives lone pair to benzene ring. Let's say like this. Okay, please. Benzene ring, and hence the availability of the pi electrons on benzene ring increases, and NH2 activates the benzene ring. Same is the case with other groups. Okay, please. Simple thing. the groups which increase the availability of pi electrons on benzene ring make benzene ring more reactive. These groups or such groups are known as the activating groups. And there are other groups which decreases the availability of pi electrons. Let's say we have the CHO group. What we have? We have the CHO group. CHO. That is your aldehyde group. CHO group. Aldehyde group. Benzene ring. CHO group, C double bond OH. So what it does? It removes pi electrons like this. And what happens? Okay, please. Double bond C, O negative. Okay, please. H here. And positive here. So these pi electrons form double bond between carbon of CHO and carbon of benzene, and this pi electron moves to the O and it becomes negative. Now benzene ring, on benzene there is positive charge. This positive charge comes here, then here. Okay. Means because of this group CHO, positive charge spreads on benzene ring, or the electron availability is on oxygen, not on the ring, and hence ring deactivates. So any group which withdraws electrons, pi electrons from benzene ring towards itself deactivates or decreases the reactivity of benzene ring. And this is known as the minus M effect. Minus M effect. The pi electrons are going away from benzene ring. Going away from, and minus means decrease and plus means increase. Plus means increase. This is very, very important. And these two facts, activating and deactivating groups, we study in organic chemistry in large number of reactions. When we carry out the reactions of benzene derivatives. When we carry out the reactions of benzene derivatives. Okay, please. Thanks. Namaskar.